Hello students, today we are going to perform a practical and having aim to prepare and standardize 0.1 normal sodium hydroxide solution.
Students, now we will see the requirement for our today's practical, that is the preparation and standardization of 0.1 normal sodium hydroxide solution. The apparatus requires for the practical are burette, pipette, beaker, conical flask, volumetric flask and measuring cylinder. And chemicals required are sodium hydroxide, potassium hydrogen phthalate and phenolphthalein indicator. Let us see the procedure for the practical. In that first one step, it's preparation of 0.1 normal sodium hydroxide. By dissolving 4 gram of sodium hydroxide in sufficient carbon dioxide free water to produce 1000 ml will give you 1.1 normal sodium hydroxide solution. The second step, it is the standardization of 0.1 normal sodium hydroxide solution. For this, weigh accurately 0.1 gram of potassium hydrogen phthalate, which is previously powdered and dried at 120 degrees Celsius for 2 hours. Then dissolve it in 15 ml of carbon dioxide free water. Add 0.1 ml of phenolphthalein in solution and titrate with sodium hydroxide solution until a permanent pink color is produced. The reaction involved is potassium hydrogen phthalate react with sodium hydroxide and the neutralization type of reaction takes place to give sodium potassium salt of phthalic acid and water molecule is removed. Now from this the observations are solution in flask is 0.1 gram of potassium hydrogen phthalate and the 15 ml of distilled water. Solution in burette is 0.1 normal sodium hydroxide. Indicator used for the practical is phenolphthalein indicator and the end point of the practical is colorless to pink. The factor used for the calculation is 100 ml of 1 molar sodium hydroxide, which is equivalent to 204.2 gram of potassium hydrogen phthalate. Now we have to convert it for 1 ml of 1 molar sodium hydroxide is equivalent to 0.2042 gram of potassium hydrogen phthalate. As we have taken 0.1 molar NaOH, so 1 ml of 0.1 molar NaOH is equivalent to 0.02042 gram of potassium hydrogen phthalate. And finally, you have to conclude your result as the normality of given sample of NaOH was found to be dash normal. Okay. Now we will proceed for the practical part.
Students, now we will proceed for the standardization of 0.1 normal NaOH. For this practical, require burette, pipette, volumetric flask, beaker, funnel and the conical flask. Okay. Now we proceed for the practical. The procedure for the standardization of 0.1 normal NaOH is we have to take 0.1 gram of potassium hydrogen phthalate. Then we have to dissolve that 0.1 gram of potassium hydrogen phthalate into a 15 ml of water. Then we have to add 2 to 3 drops of phenolphthalein indicator. And now this content we have to titrate with the 0.1 normal NaOH. Okay. Now we start with the titration. The color change for the practical or this titration is colorless to pink color. That pink color is persists for a longer time. So if you observe this conical flask, there is no color change initially. We will add a further amount of NaOH. Okay, now you can see the color change at a 4.7 ml color change to the pink color. Okay. Similarly, we will proceed for the second layer. Now fill the burette with the NaOH. Okay. Proceed for the second reading. Again, I have taken 0.1 gram of potassium hydrogen thalate, which is dissolved in a 15 ml of water, and 2 to 3 drops of phenolphthalein indicator was added. Okay, now we have to titrate this content again with 0.1 normal NaOH. Color change is colorless to pink. You can see the in point for the titration is colorless to pink. So you can observe this color change. Similarly, we will proceed for the third reading. Before that, fill the burette up to a 0 mark. Okay. Same potassium hydrogen thalate, 0.1 gram, 15 ml of water, and 2 to 3 drops of phenolphthalein indicator. And this content we have to titrate with the 0.1 normal NaOH. After titration, complete titration, it will give the end point, that is colorless to pink. Initially, you can observe there is no color change. After complete reaction, there is color change observed that gives the color to the pink. And that pink color should persist for a 30 seconds. Okay. In this way, we have completed the 3 readings. Students, from the practical, we have got the 3 reading and we have taken the mean of these 3 reading, that is the 4.6 ml. Okay. Now we have to proceed for the calculation part. So factor for the calculation is 1 ml of 0.1 normal NaOH is equivalent to 0.02402 gram of potassium hydrogen thalate. Okay. Now we have to calculate the normality of NaOH, whatever we have prepared for the practical. So the amount of NaOH required is 4.6 ml. So 4.6 ml of X normal NaOH is equivalent to, they have taken the quantity of potassium hydrogen thalate is 0.1 gram. So after doing the calculation part, so see here 1 into, by cross multiplication is 1 into 0.1 into 0.1 divided by 4.6 into 0.02402. We will get the normality of NaOH is 0.09 normal. Okay. So from this we can conclude the result of our practical. The normality of NaOH is found to be 0.09 normal. Thank you.
So students, now we can conclude the result of our today's practical. The normality of given sample of NaOH was found to be 0.09 normal. Now we will see the question bank. The first question, how you will prepare 0.1 normal sodium hydroxide. Second, give the principle involved in standardization of sodium hydroxide. Give the reaction involved in standardization of sodium hydroxide. Next, explain the procedure for standardization of sodium hydroxide. Next, name the indicator used in standardization of sodium hydroxide. Give the factor involved in standardization of 0.1 normal sodium hydroxide. And lastly, name the primary standard used in standardization of sodium hydroxide. Students, I hope you have understood the practical preparation and standardization of 0.1 normal sodium hydroxide. Thank you.